lesson is going to investigate graphing tangent and cotangent. Okay, the first thing we're going to do here is examine the unit circle. And let's do the quadrantal angles, and we'll do sine and cosine. So first of all, this point here is 1, 0. At 90 degrees, it's 0, 1. At 180, it's -1, 0. And then down here, it's 0, -1. Okay? Now, let's talk tangent. Okay, let's talk tangent. So tangent of 0 is sine over cosine, and that would be 0. Tangent for pi over 2 is undefined. Tangent for pi is 0 again, and tangent for 3 pi over 2 is undefined. Okay, let's take this information and put it here on a graph. So I know at 0, we're going to have a 0, but right there, something weird's going to happen. So let's label our x-axis here, 0. And now we've got pi over 2. And then we've got pi. And let's go to the left also. You're going to realize, you're going to notice here that tangent and cotangent are very small. We don't need to draw as much to get them done. So at 0, there's a 0. So let's go ahead and put a point, a 0, an x-intercept on the y-axis. How about pi over 2? It's undefined. So what are we going to put there? Yeah, we're going to put an asymptote. There is no graph at pi over 2, no tangent graph. But at pi, there's another 0. Okay, and this is where it gets weird, because how do I do negative pi over 2? That would be swinging down. Swinging down this way would be negative pi over 2, which is the same angle as 3 pi over 2, because those are called coterminal. And that's also undefined. So then we have to put an asymptote. And at negative pi, swinging down, we have a 0. Okay, so let me show you what a tangent graph looks like. Oh, let's maybe figure out if it's positive or negative. In quadrant 1, tangent is positive, but down here, tangent is negative. Here, tangent is positive. Here, tangent is negative. So from 0 to pi over 2, tangent is positive. From 0 to pi over 2, we have to draw positive. We have to go up, 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 approach the asymptote. What about 0 to negative pi over 2? Tangent's negative, so we're going to go down, 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 approach the asymptote. He kind of reminds me of the cubic function, x cubed. This right here is one period of tangent. So we're going to need to go ahead and draw a couple more. Here's another one. If you want to finish more, I guess you can. And then here would be 1. So maybe what I recommend doing is drawing the entire branch, because sometimes when people draw halvesies, they end up drawing it the wrong way. So I actually just drew 1, 2, 3 periods of tangent. It's okay to do more. Okay. A couple things I'm noticing about tangent. Tangent's really small. He does not need 4 sections. He only needs 2 sections. Okay, and then the time to complete a cycle is pi. So he's got a couple of things a little smaller than our other friends, sine and cosine and things. Okay, let's do the same thing here for cotangent. We're going to have 0. This is going to be pi over 2, and this will be pi. Negative pi over 2 and negative pi. So let's go look at this circle up here, the unit circle, and talk about cotangent. What's cotangent of 0? Cotangent is cosine over sine. Cosine over sine, the answer is going to be undefined. Okay, cotangent is different than tangent. Cotangent for pi over 2. Cosine over sine, now it's 0. Oh, I get what's happening here. Cotangent of pi, cotangent is undefined. And cotangent for 3 pi over 2 is going to be 0. So there's a couple of changes here. So 0 for cotangent is undefined. So he's going to get an asymptote there. So this is where the graph comes from. It comes from the unit circle. Pi over 2, cotangent has a 0. Pi, he's got an asymptote. So do you see how it goes asymptote, point, asymptote, point, asymptote? That's how these guys work. Every single time, that's how it's going to work. Now let's talk about cotangent. Cotangent in quadrant 1 is also positive. So from 0 to pi over 2, it's going to look like this, positive and then negative. So a cotangent graph looks like a cubic, but upside down, reflected. Whenever you start to do these graphs, it's going to be the same way, down to the right. You don't have one down and one up. They never squiggle and intersect or anything. Okay? One period for tangent and cotangent is one branch. One of these branches is one period. I always require you to draw 2 periods, so you need to make sure you have 2 complete branches. I did right there. Okay, let's just summarize everything so you see what's going on here. So first of all, y equals tangent of x. And then I want to look at y equals a negative tangent of x. So some things you have to remember for tangent. How does he start? A tangent starts on the y-axis with a point. He starts with a point, and he has asymptotes on either side. You have to remember that about tangent. How do they start, and how does he look? Tangent looks like a cubic, up to the right. So what would a negative tangent, a tangent reflected over the x-axis, look like? Well, he's going to go down to the right. Oh, when you reflect a tangent, is that a cotangent graph? Not exactly, because a cotangent graph starts with an asymptote. It has the same shape, down to the right, but cotangent also has a little bit of shift. So let's go ahead and summarize cotangent here. Y equals cotangent of x, and what would a negative cotangent of x look like? Well, first of all, you have to know that cotangent starts with an asymptote, and he's either to the right or he's to the left. So that's how cotangent looks. And he's got a point over here. A regular cotangent goes down to the right. That's how a cotangent looks. A negative cotangent is going to be reflected and going up to the right. So he's going to look like x cubed again. Okay? So that's what they look like, and that's where they came from. Let's go over the rules a little bit because he has different formulas. So for both tangent and cotangent, we have an A out in front and we have a B. To calculate the period, it's going to be a little bit different. It doesn't take 2 pi to complete the cycle. It only takes pi, and you're going to divide by absolute value of B. Okay, that's different. And we only need to divide the period into 2 sections. We don't need to divide it into 4. Tangent and cotangent are short and sweet. And the A value out here, this is not an amplitude. Tangent and cotangent do not have amplitudes. What does a number out in front do? Kind of like what would it do if it was 2x cubed? The number out in front would be vertical, vertical stretch, or a shrink. And I'll show you how to indicate that on your graph. Very easy. Okay, let's do this first example here. So the A is 5, and the B is 7. So let's go ahead and let's mention the 5 first of all. That 5 means vertical stretch. Okay, so it's going to be a little stretchier. And the B affects the period. The period for tangent is pi over B, which is pi over 7. Now, what about a section? Okay, we have to take the period and divide it into 2 sections. So over 7, and if I put a 2 down there also, that's going to be pi over 14. Okay, so this is how it works. 1 out of 14, 2 out of 14 is pi over 7. Stop. Really? That's it? 1, 2? That's right. He only needs 2. Let's go to the left also. Negative pi over 14, negative pi over 7. Okay? You have to know that it's just pi over b, divide by 2, and now I have to know, how does tangent start? On the y-axis, tangent is going to start with a point. And that means he's got asymptotes then on either side of that. So it goes point, asymptote, point, asymptote. That's how it works. Okay? If you know how it starts, then you just alternate the pattern. Okay, let's talk about this a little bit. I have to draw a tangent graph. The 7 was the period. I got that already. Now for that 5, a vertical stretch. Okay, the way that you show that, I'm going to draw a regular tangent. A regular dotted tangent. Okay, maybe I should draw the full thing so I don't mess up. Up to the right. Up to the right. Now I have to draw one that is vertically stretched. If I take the little arms and pull up on him, he's going to be in here. If you show me one that is taller and skinnier than your basic one, then you'll have a stretchy one. So dotted lines is enough. That's all you have to show me for those. Okay, let's go look at this cotangent graph here. The period is pi over 3, and a section would be pi over 6. Okay, so we're going to have 1 out of 6, 2 out of 6, done. Negative pi over 6, negative pi over 3. And how does a cotangent graph start? On the y-axis, he gets an asymptote. Asymptote point. Asymptote point. Asymptote point. Okay, I think we're ready. Now this is a negative cotangent. A negative cotangent that's flipped looks like the cubic. Up to the right. You don't have to do any dotted ones because there's no stretching. That's all you have to do. Okay? All right, let's do a couple more. Let's do one that has some fancier A's and B's and state some information about these guys. So first, let's get our X and Y axis drawn. Okay, and let's do a period. So the cotangent formula is pi divided by b. Maybe what I'll do is pi times the reciprocal, which is 3/2. So the answer is 3 pi over 2. And now it's time for a section. The section, I have to divide by 2. Dividing by 2, should put the 2 in the top or the bottom? Put it in the bottom. 3 pi over 4. Okay, that should work. 3 over 4. Plus another 3 over 4 is 6 over 4, which is 3 over 2. Perfect, it worked. Negative 3 pi over 4, negative 3 pi over 2. Okay, so the b value has been taken care of. That a value means I need to show some vertical shrink. Ooh, and I also have to reflect. Okay, before I start doing all that, I need to remember, how does a cotangent graph start? On the y-axis, cotangent gets an asymptote. Asymptote point. Asymptote point. Make sure you alternate. Okay, let me see this nice point, nice x-intercept right there. And I also have to show a regular one and then a shrunk one. A negative, okay, let's see. Cotangent usually looks like this. So when I reflect it, it's going to look like tangent. So let's just do a dotted tangent, or a dotted up to the right, cotangent rather. And now we're going to shrink it. Vertical shrink, it's going to get short and fat. You have to be under this one and between him and the x-axis. He gets closer to the x-axis. He gets shrunk closer to the x-axis. And now it's time to answer some questions. The domain of tangent and cotangent, they always have asymptotes. They always have some breaks. All reals except x cannot equal. The first place that there's a break is 0. Then you say plus minus. The distance to the next asymptote is, oh, that's easy, right there, 3 pi over 2n. From asymptote to asymptote is always 2 sections. 2 sections is another way of saying period. for these guys. How about the range? The smallest y to the biggest y, all reals. And remember how domain is related to asymptotes? Where are the asymptotes? Well, they're at 0 plus or minus 3 pi over 2n. Okay, now zeros is not related to them. Zeros are the points where it touches the x-axis. So they do have some, but we have to say this a little differently. The first positive one, 0 or positive, is 3 pi over 4 plus or minus. The distance to the next one, 2 sections to the right, 2 sections to the left. How much is 2 sections worth? 3 pi over 2n. Look at that. You're not going to add those because that has an n and that doesn't, and that is how you state the information. Okay, we got one more. Let's do a complete tangent graph. Okay, first of all, let's take care of the period. For tangent, it's pi over b. Pi divided by a half is going to be 2 pi. How about a section? For tangent and cotangent, divide by 2, which makes it just be a pi. Okay, x and y axis, here we go. We've got 1 pi and 2 pi. Negative 1 pi, negative 2 pi. Okay, I need to ask you, how does a tangent graph start? On the y-axis, he gets a point. Then he gets an asymptote. Then he gets a point. Then he gets an asymptote. Okay? I'm sure some of you are wondering, is it always like that? Well, what if we start shifting it? Then it's going to get more fun. But not yet. Okay, are we ready to draw a tangent? I have to draw a negative, which is a reflection, and I have to do a vertical stretch. Okay, a regular tangent graph, let's just remind myself, goes up to the right. A negative one is going to get reflected, so here's a negative tangent. Okay, negative tangent. Let's draw the entire thing. Down, down to the right. Down, down to the right. This is where people sometimes mess up a little bit. Down, down, down to the right. Maybe drawing a third one would help, not make it go the wrong way. And let's draw a vertically stretched one. Vertically stretched. Vertically stretched. That's 2 periods. I'll go ahead and finish this one off over here. Since I have numbers, you have to put some graph there. Don't leave it empty. Okay, how many periods is this? 1, 2, 3. The domain is all reals except x cannot equal. Where's the first break? Pi plus or minus the distance to the next asymptote would be 2 sections. How much is 2 sections worth? 2 pi n. Range of tangent and cotangent are always all reals. Does it have asymptotes? Of course. The first one is where? At pi. We just did this. Plus or minus 2 pi n. Okay, the first one does not get plus minus. The first one is just a number. Then it's plus minus n. This is not equal. This is equal. Zeros are different. Where is the first x-intercept? At 0. You could write that. You don't have to. Some people like to do the same pattern, the first one, plus, minus. If you'd like to write a 0, go ahead. Then the distance to the next one is 2 pi n. Some people start to notice some patterns here. How come it's 2 pi n is the space for everything? Because they alternate. Point, asymptote, point, asymptote. The space between asymptotes is the same as the space between zeros. So there will be some things you start to notice the more you practice. And I can't wait to see you tomorrow so we can do some practice.